Hi, everyone. My name is Francisco Munoz Alvarez, and today I will be shortly talking about application continuity, the missing link. I am a distinguished product manager with the Oracle MAA team from Oracle headquarters, and you can always contact me through my Oracle email that will be in the end of presentation, by Twitter or X. My handle is FCO Munoz. Feel free to follow me. And I always tweeting with regards to Oracle all the time. We also have my LinkedIn account on screen. And also you can see my personal blog, oraclemaa.com. Why I call application continuity the missing link? Because number one, application continuity is a product of a feature that surprisingly many people don't have no idea about. And second, this is a glue that missing between HA and DR. Basically, as we're going to see, is we are bringing now high availability not only at database level, but also at transaction level. So let's get it started. Before anything else, safe harbor that any of the futures that we'll be talking, the evolution of application continuity, especially with regards to 23C, could change. We never know if they are going to be fully available or not up to the moment of the release of the general availability of 23C, as per example. So the agenda of today, we will shortly talk about what's continuous availability, moving to continuous availability, maintenance without impact, and finally talk about application continuity. So let's get started with what is continuous availability. Continuous availability focus on the user experience, not in the database itself, but by the user experience by itself. One example, if we planned maintenance, we were able to hide from the users, from the application, timeouts of even unplanned outages can be hiding. The in-flight work continues and performance becomes predictable. And it's easy to achieve continuous availability today. So following AMA best practices that always deliver HA at the database layer, ensuring that the database and data is always highly available, that's the focus of application continuity. But this does not take into account the user experience most of the time. That's why AC came to the play. The data is always available, and that's what we try to protect with HA. But the user session is open to interruptions, reconnection, and restarts. And that's why we try to protect with continuous availability. The goal with continuous availability is to eliminate downtime for users. The in-flight work is always preserved. Any maintenance will be hidden. Errors visible only if irrecoverable. That means if a transaction is not able to be recoverable and replay it, only that ones will cause error and is built on top of high availability. So the next question is, how can we move from high availability to continuous availability? Let's explain the natural evolution that can be achieved by implementing continuity availability on 3 levels, by implementing basically 3 levels, because we know that try to implement everything in once is not simple. So we divided that on level 1 of implementation, level 2, and level 3. Level 1 is a basic level that focus on connections and making the connections stay connected and basically keeping them alive. Meaning if a connection fails, it automatically failover. Level 2 is to enable continuous availability for planned maintenance across instance. Basically, let's say one example, we have a rack, real application cluster. This real application cluster has 4 nodes. We have one database with 4 instances, but now in level 2, we can enable continuous availability across the instance in the rack. Level 3 is with regards to continuous availability for unplanned outages and planned failovers. That's when, one example, we have DataGuard on play, and we are doing a plant maintenance, and we are doing a switch over, and or basically the site where I have my 4 nodes of rack from primary goes down and now need to fail over to my DR data center. And basically we want application continuity to replay all the transactions that are happening over there. So if we talk about the level one is implemented, or effort is minimal, estimated 1 hour for the DBA and around 1 hour of effort from developers. Basically here you have a connection to the database, but you then lose that connection. Behind the scenes, all you will need to do is resubmit it to the database. That's what the application does, and we will take care of it. Here you configure the service as always you have done before with rack, with application cluster, and that will talk to fast application notification to know how to properly behave in case of loss of connection. Basically here, what the DBA will be doing is configure the database, the role-based database services, will enable fast application notification that basically will do that by opening the ONS ports, the Oracle Notification Service, to allow the user or the application in this case to receive via a notification when an issue happens. I just spoke before about configure role service. This is basically this is when we configure our services, adding the role information to when working with DataGar. Basically, allow the service to understand when a role transition happens, when a primary database is not a primary anymore, and when the standby database becomes a primary, and the services automatically knows that. One thing to make application continuity clear to everybody else is basically in the past, we always have kind of high availability of service with real application cluster, correct? That we have a services that spread across all nodes of my rack, my real application cluster. The difference that we have in the end, when we have it here in this example that we have here, we can also extend that service now to work across my primary environment where I have a 4 nodes rack, and now my DR environment where I have, let's see, a standby database with rack over there too. Now services can understand that both exist and manage that transition properly. So the tasks to enable the level ones are very simple. Configure the role-based services, user recommend connection strings in your application to use basically the services that you are implemented on step 1. Ensure FUN is enabled by opening the ONS ports. Basically, FUN is enabled by default with the database. And number 4, use the basic exception handling within the application itself. So when we talk about services, you have in the screen an example of a service definition. When the black part of the code is the basic service definition that we always does. And then on blue, we have the part as reference to local transparency. And in green, we have the draining part that we'll be talking a little bit more later. And the red part is with regard to enable transparent application continuity. So one example here on the screen, we have the services. We are adding a new service in the database for the database MyDB. The name of this service we'll call My Service, and I will be using this to the PDB, My PDB. For the location transparency, my preference instance on the rack will be instance 1, available instance 2, but the role that will be connecting the services will be for primary. That means I will connect to the database, the instance 1 and 2, for the database that I have as a primary, not the standby. Then I can have the drain timeout of 300 seconds with the stop option immediately. And then the commit outcome will be true. That means we want to validate the commits, and the failover type will be automatically. Don't worry about this. We'll be talking this a little bit more later too. This is one example now from the connection string that the application will be using. In this case, we're talking about a data guard example. So we will have the description, the typical connect timeout, how long will be the timeout, how many retries we're going to do, in this case 100, and how much delay will be having between retries, in this case 3 seconds. Then we have the address list with the load balancing on. In this case, we're putting the scan for the cluster site 1, that's the primary one. And then if all this fail, it don't work, we will then connect to the site 2, where the standby database is. That's a basic, very simple service definition. So the step number 3, ensuring fast application notification using, is the basic things that you have right here. As I mentioned before, FUN is already enabled by default. So basically all we have to do here is check and that the ONS ports are open. And ensure application implements reconnection logic, catch connection failure exceptions and errors during database calls. That means on this level, we always telling basically the application need to knows how to handle if an error is sent because a connection fell, and then we'll be able to reconnect and resend the transaction back to the database. Level 2 is prepare for planned maintenance. So here, the application developer uses Oracle connection pools and return your connection to the pool between uses, or use a connection test. We'll be talking this in a few moments. The DBA, what the DBA need to do in this case? Administer the services during planning maintenance option. Basically, if you have a service, I'm going to do a planning maintenance, I need to tell them, okay, this services now is not going to use this instance, going to use this instance as the preferred one. We'll move all the new connections to that new instance, and we'll basically drain the connections that we have on the instance that we are going to do maintenance. Let's say, as per example, apply a patch, and let that commit finish and be clean. And then when the application reconnects, these services will move everybody to another instance. And request boundaries, define a unit of the work. When your basically application connects to the database, they always have a begin request. Then you have the request body. Often it ends with a commit. And then you have the end of the request that you have right there. How do you use the requests in the middle? Basically, we use requests to manage draining, load balancing, recovery of in-flight work, planned failover, reset session state, performance metrics, and also to improve protection levels. So always work with the drain work before maintenance. When you do this, the services are relocated automatically and user work drains. Many places to drain need to return to the connection pool. If you're using connection test, the connection test will get a notification and will add that connection now is closed and move. Log off or basically a planned failover by itself. When you prepare for a planned maintenance, the recommendations are always to enable draining. Use an Oracle connection pool or ensure a third-party pool with request boundaries. Alternatively, use the connection test to release connection in safe places. Ensure sufficient node capacity is available on available instance. You cannot just stop all of them at once and expect everything to work. You need to have a survival instance in a rack, one example, to be able to drain and automatically fail over the service to the other side. If your application can drain in real time, it must drain prior to maintenance. Basically doing the drain of the connection and the application, and then we need to handle and redirect to another node of the cluster. Oracle connection pools of user request bundles. Applications use it one example, Oracle pools like WebLogic Active Grid Link, UCP, ODP.NET, Manage It and Unmanage It, OCI Session Pool, or even Tuxedo. Also works with third-party application servers using UCP like IBM WebSphere and Liberty, Apache Tomcat, NEC Web OTX, Spring, or Red Hat Wildfly JBoss natively. DBAs uses service CTL, SVR-CTL, relocate the service that you're going to relocate, and the drain timeout, telling how long will be the drain to allow all the transactions to properly finish and timeout. Or you can basically stop a services. And the session then will automatically will be drained automatically. Immediately new work is redirected. Idle sessions drain gradually, and active sessions are released when returned to the pool. No request of boundaries, then you use what we call connection test that comes to work with that. Basically, the application run a small code just to check that the connection with the database is alive. Many applications to view the connection tests that are currently available within the database or in use, you can use the view DBA_connections_test, and you can add more tests if your application is using a different kind of string for connection using the DMS_APPP_cond admin package. And this is one example of the database side. You can see this example of connection tests, that SQL tests that are being done using the select one from dual, select count from dual, select one, begin, new, end. That's our enable in this case. And also have examples like a ping test of end request test that in this case is not enabled, not available. But you can see on that view that I just mentioned before, right here, DBA connection tests, which connection tests are enabled by default with your database. And then you can use this package right here to enable any SQL test that your application uses to check, do that ping to the database and check the connection is still alive. And then you have level 3. Level 3 is the one that takes longer time to work with. Yep, level 3 is basically continuous availability. Is like when the developers have a lot of work to do. The DBA also have a lot of work to do. DBA grant additional security and privileges. The application developer drive a configuration, take external actions, for example, side effects, and both basically work using in coordinate to ensure readiness using a package from Oracle that called ACC check. This is where basically we're going to verify which transactions are using application continuity to replay the transaction for planned and unplanned situations, and which not. And you can see with ACC check why it's not being using, what problems are using, and so on. So continuous application replacing flight database requests. This is when the replay now comes to play, because we want to make the transaction high available too. That means we not only want the application to be able to reconnect automatically in a service failover by itself, but you want when the service failover, any transaction that was happening in the node that went down to be replayed automatically in a survival node. Why we want that? Basically, this way we hide any error from the application. If I throw a transaction from my application and I press it, and one node goes down where this is happening, basically they will return an error to the application. The application then need to reconnect, rerun, and then they will connect to another service, another instance through the service failover. But with the application continuity part of the continuous availability, if you have that level 3 enable, basically the application will not get any error, because The user sensation, the user experience is that, oh, my application is a little bit slow. Maybe my internet's a little bit slow. Oh, finish. But they have no idea in the background that one of my instances fell, or my whole primary site went down and a failover happened, because all the transaction that was working right there in the the database, they fell, will be replayed in my stun bias, for example, on a survival node without the user even know that an error happens. That's why the beauty of application continuity, it hides all that possible downtime, give it basically a logical zero downtime. And this is basically when an example of unplanned outage without impact. Number one, the database request is interrupted by the outage. Let's see, I have a 3 nodes rack, and the first node goes down. Then the application that the session head reconnects to the rack cluster, and the database request is replaying a survival node automatically. And then the user receives the information to the application. And basically no error came anywhere here. They don't have no idea that the node number one, that's the request were being run on node one that came down, and then a failover happened to node two, and that transaction was replayed to node three. When this come right here, when the replay happens, it's very important to know that we will never commit twice. That means this is very smart to know when which parts of the transaction, of the whole transaction, was already committed, and they will not double commit when do the replay. Other smart thing that many people think is the logic that was being read before they fell is maintained. What I mean with that, let's see one example that the transaction was running on node one, and it was reading a sequence. That sequence was giving number 100. When moving now to node 3, as per the previous example, we will expect when they run the sequence again, they will now show 101. No, they will see 100, the same number that the transaction was seeing the previous node before the failure. We keep the integrity of the data at that level too. For plain failover, automatic failover in the session, they're unlikely to drain. You have the features that basically the database rules engine activates on the session market to drain and forces the failover. It's used in automatic load balancing and in maintenances, including, one example, outer system disconnect session, the SID, the serial, post-transaction force drain, timeout of 30 seconds. The benefit when we do this with a planned failover is early draining and more successful failovers, predictable short maintenance windows, and support for long-running database requests also. We have two flavors of application continuity. When we talk AC, we have the plain AC, and then we have the transparent application continuity. Application continuity, the normal AC, came out with 12C. That means it can be used for 20C and up. And they use basically Oracle pools. The application should return connections to the pool, and it's very simple and customizable. Basically, all the logic, everything will be managing at the Oracle pools level. And the transparent application continuity was created at 19C for people that basically not using Oracle pools. And because they are not using Oracle pools now, they were unable to use AC. So transparent application continuity was created from 19C. That means you need to use it for 19C and up, and worked with or without Oracle pools, discover request boundaries, re-enable automatically after a disable, and decisions are made for you. So when we do the comparison, you have a table right here with many different comparisons. I will not go in deep on this because we have so many things to cover. I don't want you to lose, to miss yourself. And I also want to try to show you a small demo of how application continuity works if I have enough time. And application continuity considerations, return connections to the pool when using our OCP, Oracle Connection Pool, yes. That means in this case, if your application works with Oracle Connection Pools, use AC for maximum flexibility. If you do not use the OCP, Oracle Connection Pool, you need to use TEC for simplicity. For failover and restore of a service, for restoring session state due to alter session commands, automatically enable in the service config. Wallets are required for some uncommon session states too. Application continuity, more application continuous consideration, side effects. If it is executed from a PL SQL, TAC will not replay external calls. AC will replay external calls, but and also can be customized. And to restore original values during replay the original values of sequence, sysguide, or sysdate. That's I mentioned before that it always replay the original value as what was happened before the transaction being replayed. Always know your protection coverage. If you run the AWR systems, you can basically take a look on cumulative user causing requests equals community user call protected. That's very simple and to understand. If the total number of user calls requested by the application to the database is the same of user calls protected, fantastic. That means my implementation of AC or TAC is fully protecting all transactions. If the user calls in request is higher than the number of call protected, that means now we have a number of transactions that are not being protected by AC or TAC. When we have that kind of situation, then it's when AC check comes to the rescue. Application continuity is basically the insurance policy. The AC check deciphers defined prints of insurance policy were not covered. That means you can have an example on the screen that you will execute the BMS app continuity report package .act reports, and then you're going to generate the report, and you're saying full here because I want the full report. We're going to see this in more detail in just a moment. And then you're going to see the level of protection that you have it, and then you will see what's not being protected to allow you to understand that. Before 19C, that basically you could use the AC check, but that was part of the Aura check itself. From 19C, now is embedded on the database itself, and you can start using without no problem. So how will we implement AC check? First, we're going to create AC check views in roles for Oracle Database 19C. Before using application continuity protection checks for the first time for Oracle Database 19C, we'll need to manually create AC check fields in roles in your database. How I do that? Simple. I connect to your Oracle pluggable database, your PDB using SQL Plus, and then create the application continuity protection checks view and role for a database by using the DMS underscore app underscore contin underscore admin dot AC check underscore view procedure. Just basically do I execute the package, done. And that will create the views for you. Then I need to enable how to enable or disable the application continuity protection check. To enable, first I need to grant read access to the users who run the application continuity protection check report and views using the AC check underscore read role. And that will be grant AC check underscore read to user X. Then I will enable application continuity tracing for your application using the DMS underscore app underscore cont underscore admin dot AC check underscore set true procedure. That will basically enable application continuity for tracing. And using the DMS underscore app continuity admin ACC check set false if I want to disable. That means with settling to true, you enable AC check protection, change it to false, you are disabling it. That's simple. Then how I run the application continuity protection check. First, run a set of database options after enable AC check. That means I will enable AC check right here, enable the tracing. Now I basically run the workload that I wanted to review. When I do that, then I generate the application continuity protection check report using the DMS underscore app underscore content underscore report dot AC check report procedure. To make it that simple, I will do a set server output on format wrap. Then I will execute the report. By default, it generates as a summary, only with summary details. But I can also generate is saying I want a full report. I just want a report of the warnings, or I just want the default that's the summary. And then I will analyze the report and increase the protection level for the applications that are not fully protected. This is one example of the report generated by the application, and you will see the event type is disabled and so on, was a commit, a SQL plus, and so on, and you can see all the details. Application continuity is evolving since it was launched the first time on 12c. That you can see everything that was evolved with planned maintenance and unplanned maintenance since pre-12c, from 12.1, 12.2, 18c, 19c, 21c, and now with 23c coming, we have some new functionalities that we are very excited to announce with evolution of application continuity. That's now it's supported when you use it your standby database to do a rolling upgrade. That means before, your downtime that you will have when executing a rolling upgrade is the time of the switch over, because you upgrade your standby database first, then you do the switch over, and then you upgrade your old primary after that. And the only downtime that the user will have will be the switch over. Now with 23c, you're going to be able to use the AC to hide that failover timeout and basically simulate a zero downtime upgrade. You can use a database initialize plan a failover during draining. And also you have application continuity advanced cursor handling now with resumable cursors with TAC and reset states. Also, application continuity drivers update, ODP.NET support for managed clients, and GDBC consolidated driver. That's all new with 23c. Now in 23c, transparent application continuity is 40% faster failover for selects, up to 50% lower database CPU cost, and up to 55% lower client CPU cost too. So in summary, ensure you are at least on level 1, that you have created the service to be able to manage a connection failover in case of, one example, a node goes down, or basically your primary goes down, and then you'll be able to understand that the role is changing from standby to primary. Application continuity is within reach. If you have a rack, you can start to benefit now. Very simple, having level 1 and level 2 implemented. And then go further if you have Oracle OCP, that's very, may simplify all the process by using AC, very simple. You have some reference material on the screen, and also on my blog. If you go to oraclemaa.com, go to reference links, you will see a section dedicated to application continuity. You have many links to documents, tutorials, and so on how to use application continuity. So saying that, I will now run and show you a short demo. All right, in this demo, I have my database rack with 4 nodes running. Basically, I have a node 1, node 2, node 3, node 4. I have 2 connections of Swing Bench enabled right here. One using the normal HA connections of a service, and 2 is a service we're using application continuity high availability. So, and then we will simulate that we will, one example, kill the services and bring down the instance on node 4. So let's see what's happening in that case for it's the application that uses a normal service with HA and the application that will be connecting and running transactions using application continuity set. So there we go. As I mentioned before, this is an example of the 12C database with application continuity. And let's take a look how everything works. We have two instances of Swing Bench, both connected for 4 node clusters. We know that, and now we can see right here, this is using the connection of the Swing Bench using the normal HA, using fast connection failover. And then we have the application continuity service connecting string right there. So that's the two examples we have. Both loads generates are configured identically and are using Oracle Connection Pools, UCP. So now let's get started. Both Swing Bench environments to start loading transactions to the 4 nodes rack. Good. In the right side, we can see CPU, IOPs, user commits, time weighted, and important in the top, you can see all the users transaction connected to the 4 instance. You can see instance 1, 2, 3, and 4, and the 4 is the pink one. So next, what we're going to do is simulate the failure. Now we're going to connect to the node 4, and I will kill the Oracle process of that instance. Okay, select the process, let's kill it. Now we kill it. All right, now that we kill the instance on node 4, we start seeing messages of disconnections for the failure coming to Swing Bench, that they lost this connection to the instance that will be how the transactions were running on node 4. But you can see the one using application continuity did not have any disconnection. You could see here in the screen on yellow that they got the disconnection. You can see transactions per second drop it, but the user never received, the application, the Swing Bench never received any error. And you see right here in the right side in pink that our users were disconnected by the node 4 because they went down. And here's what I was mentioning, that the application, the transactions from this application connecting using application continuity saw that node 4 went down, but they were automatically reconnected and no errors were received by the application. They were hiding by application continuity. But when you using the same application using a service that is not using application continuity, it received errors and was forced to reconnect, resend the transactions to the application, handle that. But the errors were perceived by the application, and of course, if it was a real person in the back, they will receive an error too. And that's basically how application continuity works and how it handles that hiding that errors, doing the replay, and keeping a good user experience. So this is basically what I have today to talk about application continuity. I do not know if there's any questions up to this point. I was just checking the chat if there's anything right here. Again, you have my blog, oraclema.com. When you have our links to take a look over there, I will be uploading this presentation there too, and I was sharing with Nassim and the Saudi Arabia, Kingdom of Saudi Arabian user group to them to share with the members too. On the screen, you have my Oracle email to contact at any time. You also can find me in Twitter. My handle is FCOMUNOZ, and also on Twitter, and I'm always available to work with the community as best as I can. If you are implementing application continuity or thinking to implement application continuity, you have any questions, please feel free to contact me. I can try to help you with the implementation. And also we have a tutorial on Live Labs. We have 2 of them that teach you step-by-step free on how to use application continuity and using Oracle Cloud and OCI. And without you need to enter a credit card of anything, Oracle Live Labs will deploy the environment for you on OCI for free, and you will play there with no problem. If your lab is for 2 hours and you are not able to complete in 2 hours, you can still extend your time of the labs 4 times, and only then the lab will time out. And then if you need it, you just launch the lab once again and start all over with no problems. But I recommend you also to play with in the live labs. Let's check if there's any questions. And okay, got it. YouTube live stream, I can see. Can you please describe about GSM? What is differ for application continuity? Okay, all right. GSM only redirects services by itself. And basically, GSM allow you to stretch your services across different regions. That means you can have, let's see, Golden Gate. And in this case, you have a Golden Gate between 2 sites, and you can use GSM to load balance, manage the services regarding to lag, because with global services, you up from 19C, you can manage the lag for DataGar as before, but also to Golden Gate. And it only manages the failover of the services. That means you always have an error. As we saw in the example with the swing bench, the application will always see that error coming, and then they will be to reconnect it, and GSM will basically will manage it that, or GDS, not GSM. GSM is the manager, but GDS, Global GSM, will then manage the failover, but they will have the disconnection. If you use GSM when using DataGar, like a farm of readers and plus the primary or a failover between a primary or a standby, AC will be able to hide that downtime with GSM too. Because it's very similar that what you manage the services on level 1, level 2, that will be managing the services by basically by GSM itself, GDS. By GDS itself. And in the background, if you're using AC, AC will hide the timeouts, will complement. But remember, AC do not work with Golden Gate. Then you need to play around with having each Golden Gate to have a standby database to protect. That one example, I have site A with a primary of a Golden Gate. Site B, I have primary B. Then site A has a standby of site B there, and then site A have the other one. That means you have a cross standbys and so on. That means if you use a GSM, you will be able to do all the failover of the services with no problem. If you're using AC in the background, when you lose site B, they will fail over to the standby on site A. That will reconnect using Golden Gate between now the 2 primaries. And then the AC will use it at the standby database to replay all the transactions were happening on site B when it fails, and then Golden Gate will replicate and synchronize both two. They basically complement on top of them. Hope that answer your question. I don't know if there's any other questions. If it's not, feel free to contact me anytime via Twitter, LinkedIn, email, no problem. I'm always here for you guys.
Francisco, sorry to disturb you, interrupt you. So in this case, can we say that GSM is similar to the role-based failover, which we can configure by putting a trigger that if this is a primary, then connect to this site, or if means the trigger will be there in place and the service will be created, And for the primary service, it should connect if the role is primary. So that in that case, as you explained, what we understood is if it is failed over, in that case, the existing transaction will be cancelled or rolled out, and it will not replay. But in
Correct.
case,
If you're not using GDS, by example, if you're not using GDS, you need to use the normal services on level 1. If you use the GDS, you will use the GDS to manage level 1.
okay,
With GDS, one example, the change when you create the connection string to use the GDS, basically you are not using the scans. They will basically now connect to the listener of the the GSM, basically. They
okay,
will skip that. But basically, you will, if you not use the GSM, you will lose the services as normal as you use with rack for level 1. If you use the GDS, then you will set up level 1 to manage the services using GDS. And in the connection, in the configuration of the services with GDS, you can use these two parts right here, extra.
thanks,
You
thanks.
will set up the draining and will set up the parameters for the service for application continuity on the GDS.
So in
Because
case of
remember,
in case
I'm
of
sorry,
normal rack configuration of 12C, if the node goes down, the existing transaction will get replayed on the another node itself, or how it will be?
with the which one? In the normal one?
The normal rack configuration of two nodes, say,
Yes.
if the first node goes down for any unexpected down, then the existing transaction which was going on that node will get be completed on the second node as it is, or it will require to resubmit from the application side again.
Basically, what you're going to do is there will be, if you have that in the service that you create for the rack, that the preferred instance is node 1 and the available instance is node 2, and then node 1s go down, then they will replay, they will automatically fail over to node 2. Because they will, when trying to reconnect, they will detect by the fan that the notification then node 1 is not available, the available one is not available anymore, then they will automatically fail over for the available one. If you
This
have
is
a
the
4
this,
node racks, you're going to put one or two as available and then preferred, and then the others as available for the services, for example.
this will be the case if we configure the AC. But in normal scenario, I'm asking, in normal scenario, if we do not.
No, with no AC. When you configure a service as a normal service for rack, this number one is normal. Number two, the green part, the blue and green is normal one. Only the red part is you enable to that service application continuity. All the failover part, now that is normal. Is the normal configuration of service for rack and the normal configuration of services for GDS. Only the red part is the application continuity part.
That is okay. This, if we don't do these things, just a normal installation we do for rack and grid installation. With that option, if the one of the node goes down unexpectedly, then the existing transaction which was going on that node what will happen to that? This is general question. We have not done any AC configuration or all these commands which you have shown here. So in that
That's
case,
correct.
yeah.
The level 1 and level 2, you can enable with or without application continuity. And the level 1 is just to keep the high availability of the servers. You can enable without AC. And that is only to allow the failover of the service to happen.
Okay.
Within a rack, one example in that case. The level 2 is basically, that's when you manage where are you? Sorry. The level 2 is basically just to manage the draining part. That's when you're going to do the planning maintenance, that you're going to do the manual failover of a service, because you're telling that you're going to do a maintenance, and you will manage the draining of that connection. And level 3 is when you implement the application continuity itself to replay the transactions to and hide the downtimes. That's why level 1 and level 2, you're not implemented AC yet. You implemented high availability on service level, and you are going to implement it how the draining will happen for plant maintenance, basically. And the application also in level 2 will handle that if they need to be able to handle that. If they receive an error for disconnection, they need to replay what they're going to do, how they will handle that exception. If a timeout happened, and if is a error happened, was notified by ONS, what is going to do? That's on level 2 too, but it's not AC yet. The AC is the level 3 basically. Then you're going to have it implemented in the service, the red part, and then you're going to start managing on the basically the reasons of why things are not being protected. As per example, the application is using a VDollar virtual environment, a view of the database, then the data, the information on it's dynamic. It's different every time you read it. That means if you're using a VDollar in one transaction that you're running with the application, AC will not able to replay that because they know that if they read a VDollar in one moment and read that, because it's the dynamic view, the data will be different. They will not able to reproduce that and things like that. But that's level 3. That what you're saying about the service to the rack is what the normal behavior that you have when setting rack, that you can do the load balancing of the services across all nodes, and also you can manage the normal failover in case of the services in case a node goes down. That's basically ensuring level 1, and that's basically most of the people already have that one. And also opening the ONS ports to be able to application to handle any error on level 2, and also ensure that the draining times now are added, setup is added to the services. And in case of a planned maintenance, the connection will be able to drain the transactions were running in the instance that will be drained, and the maintenance will happen.
Thank you. Thanks a lot.
It was a nice question from Anis. So, do you see any more questions, Francisco, from your side?
No, I just see the ones I already responded. I cannot see any other one. Do you see any other one?
No, nothing.
So this AC we can implement from 19C onwards. Huh? No issues whether it's a
from 12C onwards. AC from 12C onwards, and transparent application continuity from 19C. That means if you use the 12C onwards and you use the UCP, Universal Connection Pools, then you can use the AC. If you're using and you're not using UCPs, then you need to be on 19C or onwards to be able to use it, a transparent application continuity that was built to allow people to make the user of application continuity when they're not using UCPs, Universal Connection Pools.
And no limitation for whether it's a container database or non-container.
For the 12C now, in 19C either. You can use with pluggable database, non-pluggable database, with containers and off containers. Of course, for 23C onwards, you are only able to use with containers.
So 23C is coming only with
21C, sorry, from 21C onwards.
Okay. So 21C cannot be configured with the non-container database?
No, that's deprecated and already not valid. 19C was the last one that enabled a non-container implementations.
Okay. And how about the support for that 19C container non-container database will prolong?
That's I need to double check how the support's going, but you still have an extended support for a few years.
Okay. Thank you. Thanks a lot for such a informative session and knowledge boosting.
No, it's my pleasure. It's always a pleasure to be invited by user groups like yours, and especially for this user group that is always on my heart.
Of course, we are very much thankful to Naisam as well for arranging all this and providing us with such a knowledgeable consultants and Oracle GMs.
Thank you.
Thank you. Okay.
All right. Looks like it's no more questions. That means if you guys are okay, please feel free to redirect any questions you guys receive later, and everyone else can contact me directly to my email or to my what's the name, my Twitter account, LinkedIn account, or so on. Always happy to help.
Thank you so much.
All right.
Francisco,
Thank you, everyone. Yep.
Francisco is from where?